We're going to go next to Marshall Space Flight Center in Huntsville, Alabama, where Lori Meggs is standing by live to tell us about a VEGGIE's experiment in space. Lori?
Well, it's vital for astronauts to learn how and be able to grow their own vegetables as we further explore the solar system. But what would it take to grow a garden in space? Sounds easy, but is it? Joining me now is Paul Zamprelli, and Paul, I'm told that you might know the answer to this. You've got a new experiment going up, and I like the name. It's easy. VEGGIE. I can relate. Tell us about VEGGIE.
Well, VEGGIE's it's been a 10-year development based on an SBIR, or Small Business Innovative Research, with NASA, working out of Kennedy. It's a plant production system, basically, that's going up, very interactive with the astronauts to be able to grow food, lettuce, and a whole dietary plan for the astronauts for nutrition.
So how does it work?
So basically, the unit is a box. It has LED lighting, and it actually, you can see it there. It has LED lighting that is an accordion type, and the plants grow as. And it is very interactive with, and the astronauts can touch and feel and tend to it just like a real garden.
So we're growing lettuce.
We are. The first mission as it goes up, which is slated to be on SpaceX 3, will grow lettuce and take a look at the growth pattern, and then it'll be harvested and brought back down for research on the lettuce itself, looking for microbials or any kind of impurities that may hurt the astronauts if they eat it.
And this is really the first of its kind, because this is going to have crew interaction, and it's also going to grow off the cabin air. Correct.
Most of the science, there's been a lot of plant science put on station, but it's all been encased and very hands-off. The environment has been very strict with it. This is open to the air, being able to grow on the air that's in the cabin itself. So it's different.
Now it looks red, but it's not, right?
No, that actually, it's the LED lights. What we do for low power consumption, we take just the light a plant needs to grow. That light is a lot of red and some other blends. It matters what type of plant we have in it, but Dr. Morrow back at Orbitech has been very instrumental in being able to do the right pitches for the plants. There's a lot of science that goes into it, but it makes it grow very fast and efficient.
So what is the science mission here? We're going to grow it, harvest it, then they won't eat it, right?
Correct. No, it has to be flown back down and then analyzed. And then once that is approved, then they can start growing and eating it as a supplement for what they're doing on station.
And you have a unit here,
I do.
Right?
This actually is what we call a pillow, and it has a spigot to inject the water into it. It's a manual injection, and this goes inside of the plant unit, and then the plant just starts growing out of here, and it follows the track of the light, just like normal plants do. The challenges that we have with zero-G is to keep everything encased, all the soil, the nutrients, the seeds. We can't have everything flowing around because it is open to the cabin, and we don't want any of the impurities or any of the call it dirt to get out, and it grows very cleanly. And this material is a Kevlar material, and we're very happy, and this was co-produced or co-developed with NASA and Orbitech.
And growing a garden is just not good for the return there, but it's also good for mental health, right?
Absolutely. There's been a lot of science done, and we work with the University of Wisconsin in this as well. And the environment of a plant or plants have been shown to create a stimulus inside of the human being that is all goodness and wholesome. And especially on long duration space and some of the terrestrial applications too, for here on Earth, it's very good for the brain.
And why did you want to grow plants in space? What brought the interest about to your company? And
well,
how did you get involved with NASA?
Our owners, Dr. Eric Rice and Ron Teeter and Tom Crabb, they have a vision, and their vision is for humankind out in space, not only habitating the moon and Mars, but long duration space. And plants play a big part in that. And of course, with Wisconsin and that influence on growing and farming and everything like that, it was just a natural in this area to be able to do that. So we're very excited. Our engineers, Robert Richter, Ross, well, I don't want to forget names here because Ross Remaker, Jim Harris, and Dr. Morrow have worked very hard, and the owners have given their careers to a lot of this science that is now going up on station again, and we're very happy about that.
When will we see this on station?
So it's slated to fly February on SpaceX 3. So we're very anticipating that and want to get this up and going. We're going to first grow lettuce, but when that comes down, we've also got loaded pillows to grow flowers.
Oh,
while they're waiting
nice.
on that. So, you know, it's just we're going to
spiffy
keep
up
it
the
going.
place up there, right?
Absolutely. it's and there's zinnias. That's what it's.
Okay.
I wrote it down to make sure and I remember that.
And tell us about the earth applications. I know there's a lot to that as well, and kids can get involved too, right? They have before.
Right. Yeah, it's a very good STEM program. We've actually made some space gardens here that we have put into the schools. The Astro Garden that is like this unit has been on station many times, growing, and we love to interact with the universities, elementaries. They can actually grow what the astronauts are growing up on space, or on space station. And you know, one of the things I wanted to do was thank some people on this with, and I need to mention the NASA folks. Our cooperation with NASA has just been wonderful, and especially with Kennedy on not only this, but advanced plant habitats and things like that. Just to mention a few, and I know I'll make some people mad, but Brian Onati, Joya Massa is the lead scientist for the science that's going up out of Kennedy. Nicole Duffer, Tori Long, Luke Robertson, and Monica Solar. The other is the support we've had from NASA Washington, from the NASA brass with this project has been great. And Charlie Quincy and Mary Beth Adine, and of course Julie Robinson from the Johnson Group have just been outstanding for this. The SBIR program works. We're able to do a lot of things with the SBIR program. We've enjoyed a bunch, which we then commercialize, which we're commercializing this as well. But the SBIR office of Jennifer Van Pelt and Michael Vincate, it was wonderful. They did a wonderful job with us, still doing that wonderful job with more and more projects that we have on this.
Well, Paul, it takes a village, and we thank you for sharing with us today. We can't wait to see VEGGIE launch next year. And that'll do it for us from the Payload Operations Integration Center. Now back to you at Mission Control in Houston.